Okay, let's take a look at our lesson for today. What we're going to be working on is actually classifying the different kinds of conics. They're all going to be in general form, and we're going to work with them and put them in standard form and graph them. That's our goal for today. So as we're going through and looking at them, what I would like to do is we want you to be able to look at the equation in general form and be able to anticipate what kind of conic it's going to be. You know, what is this going to be? So we're going to go through each of these equations and talk about how can I tell what it's going to be. So as we look at this first one, we notice that there's only one squared variable. Okay, only one squared variable. Since there is only one squared variable, this is definitely going to be a parabola. Okay, so that's how we can tell before we even start working with it what kind of conic it's going to be. So this is a parabola. That really helps me as I start with my work trying to decide what to do. So this is a parabola. I'm going to keep the squared part over here on the left side, and I'm going to go ahead and move the constant and the y on the other side to start the process. Okay, so we would complete the square. All right, so half of 4 is 2. 2 squared is 4, so I would add 4 on this side and add 4 on this side. All right, so we see to clean that up, we're going to factor. So this factored would be x plus 2 squared equals negative 4y plus, let's see, 16 and 4 is 20. Now, if you recall what the standard form looks like, that standard form requires that the number in front of this y be 1. It's not allowed to be anything but 1. So what I have to do is I'm going to have to factor the negative 4 out of both of these terms on the right here. So let's work on that. So x plus 2 squared. Okay. So let's see, I divide that out. And when I divide out a negative, recall it's going to change this sign. When I divide out a negative, it's going to change this to negative. All right, making progress. So this right here, this number should not be with the single variable. This number should be with the squared variable. That's where it's supposed to be. So the very last thing, and I would be able to tell that by looking at the standard form of the equation. So what we would need to do is actually divide both sides by negative 4. So we're going to divide by negative 4. And cleaning that up, and I really like the single variable on the left side, so I'm just going to reverse the way that I'm writing it. So I'm going to have y minus 5 equals negative 1/4 times x plus 2 squared. So now my equation is in standard form. So I want to pause there for a second. So how are we doing? So hopefully what this lesson does is it just really solidifies the things we've been working on for several days now. Because we spent time working on all these different kinds of conics, we're just bringing it all together. So what they're asking us to do is write the equation in standard form and then graph it. And so I'm going to write out to the side some information. I mean, they're not asking me to list things, but I think it's just going to be easier for me to work with if I go ahead and just write out what the vertex is going to be, which if you recall, we get straight from the equation itself. So the vertex is at negative 2, 5. All right, so let's go ahead and plot that. Negative 2, 5, 1, 2, 3, right here. Now, in order to graph the parabola, it would be most helpful for us to determine the length of the latus rectum, you know, the focal diameter. How wide is the parabola going to be? So these two formulas, I'm just going to remind you, these are ones that you would be memorizing. Right, A equals 1/4p. That's memory work. And then you've got absolute value of 4p. That's the the distance or width of the focal diameter, or LR. So we're going to use that to help us graph. So that's what we're going to do. So we know A is negative 1/4. So negative 1/4 equals 1 over 4p. We would cross multiply. So 4 times 1 is 4, times negative 1 times 4p is negative 4p. So p would be negative 1. All right. So if you recall, the way that we would place this would be depending on which way this one is going to open. When y is to the single power and x is squared, that means it's going to open left or right, up or down. It'll be either up or down. Do you remember how we decide whether it's going to open up or down? What would that be? The sign of A is negative, so this one's going to open down. So that means that this distance of 1, so P is going to be right down here. To find the width of the parabola, I would substitute P into this little formula, which I would have memorized is 4. So that means I would go 2 spaces to the left of the focus and 2 spaces to the right of the focus, and that's going to tell me how wide to draw my parabola. So my parabola would start here at the vertex, and then it would go through that location, and then go through this location. And then the last thing that I would need to draw, so I've got the parabola, I've got its little focus, I need to draw its directrix as well. And if you recall, the directrix is equally distant from the vertex. So if the focus is 1 space from the vertex, so is the directrix, but going in the opposite direction. So my directrix would be up here, 1 space away from the vertex. Okay, how are we doing with the parabola? Does that bring back some memories? Okay, so I'll just put a little asterisk by these two. You need to be sure to have memorized those. And they just have to do with parabolas for us. They just have to do with parabolas.
Can you go over why you want 2 spaces to the right and 2 to the left?
Yeah, absolutely. So this distance 4, this is the distance of it's called the focal diameter or the latus rectum. And what that means is when you draw through the focus, there should be 4 spaces total from one side of the parabola to the other. And that's measured through the focus point. So that's what the significance of this 4 is. It tells us how wide to draw the parabola. And the 4 is the total distance. That's why we go 2 on either side instead of 4, because that number, whatever it happens to be, is the total distance between the edges, the little points of the parabola. Okay? Any other questions? All right, let's work on our second one. Okay, again, I want you to be comfortable with looking at the equation in general form and figuring out what it's going to be. So let's look at this. I've got an x squared and a y squared. Okay, and I have a plus. And there's no negatives, and none of those are negatives. So x squared, y squared, they're both positive. So that means this is either going to be, it's going to be a circle or an ellipse. Okay, so we need to investigate further. So we've got x squared and y squared. They're both there, and they're both positive. Those are positive. They're being added, and both of those terms are positive. Circle or ellipse. So how am I going to be able to tell? Well, the way that you tell is by the numbers in front, these coefficients, these two numbers. Okay? Since these numbers are the same, since these numbers are equal, this is a circle. Okay, so this I'm going to circle. This is going to be a circle because those two numbers are the same. The 15s are the same. Now, it's actually kind of helpful to know what it is that we are, working on rewriting so that we know how the formula is supposed to end up. So this is supposed to end up looking like a circle, the way the circle would look. Okay, so let's start on that. So we would group, I'm going to group the x's together. So I got 15x squared minus 150x, leave some space. Then I've got 15y squared minus 30y. And I'll move the negative, or move the 330 over, so negative 330. Now recall, I cannot complete the square if the number in front of the squared variable is not 1. That has to be a 1. So I have to factor. Got to factor out of those two terms. So we factor 15 out. So I've got 15. Let's see, that gives me x squared minus 10. 15. That gives me y squared minus 2y. Okay. So hopefully by now this is becoming more comfortable for you, working through the completing the square. Hopefully it's becoming more comfortable. We've been doing it for quite a while. So we take half of b, half of 10 is 5. 5 squared is 25, so plus 25. But I really am not just adding 25 over here on the left. I'm really adding 15 times 25 is what I'm really doing. So I'm really adding 375. That's what's really going on. All right, so now let's do the second one. So a half of 2 is 1. 1 squared is 1. I'm adding 1. But in reality, I'm actually adding 15 times 1, which is 15. Okay, there's my completing the square part. So now I have 15 times x minus 5 squared plus 15 times y minus 1 squared is, and I add all that stuff up and I get 60. Okay. So let's recall this is a circle. Yes?
Sorry, from which part of the equation did you get 25 again?
So what I did is I took 10 and I halved it and got 5, and then I squared it and got 25.
Okay, got it.
Yes, ma'am. Half of b squared is the little formula for completing the square. Okay, anything else? All right, so recall that with a circle, there's not supposed to be like fractions, like over and equal to 1, right? That's not how a circle looks. Instead, we're going to divide through this whole thing by this same number, 15. That's how it's going to work. I divide each of these things by 15. So that gives me x minus 5 squared plus y minus 1 squared, and 60 divided by 15 is 4. Okay. So let's write out some information for ourselves. Our center, the center of our circle, is going to be at 5, 1. So let's go over to 5, 1. 1, 2, 3, 4, 5, 1 right here. Okay. Our radius is the square root of this number. The square root of 4 is 2. So our radius is 2. So when I go to graph this circle, I'm going to go 2 spaces to the right, 2 spaces to the left, 2 spaces above, and 2 spaces below to get some points. That's going to give me the shape, or at least the outline of my circle. And then I simply finish drawing it. So we've got Okay, there's our circle. And really with the circle, all they want to see is the center and the circle. They don't really want to see anything else. We don't have to worry about other parts of it. So it's just the center and the actual circle itself. All right, how's it going? We doing okay? Yes? Okay. We have a couple of more on the next page to work. So let's go there. All right, again, we're going to analyze. We're going to kind of look at this general equation, try to figure out what we got that we're working with here. So I've got a squared and a squared, and both of these are positive. Okay, that means that this is a circle or an ellipse. That's what it is. And how do we tell it apart? We look at the number in front of both of those squared variables. We look at those numbers. Those are not the same number. They are not the same. So that means that this is an ellipse. Okay, this one is ellipse because those numbers do not match. Okay? All right, so let's work on our process. So we've got putting the x's together, 25x squared plus 50x, leave some space, then we've got 16y squared minus 320y, and we move the constant over, and that's a negative 1225, 1,225. All right, so we know from our previous experience, these numbers that are in front of the squared variables are not allowed to be anything except a 1. So I'm going to have to factor those out of each of the two terms. All right, so we factor 25 out, and that leaves us x squared plus 2x. We factor a 16 out, and that leaves us y squared, and 320 divided by 16 is 20. Okay, so that's our next step. All right, now we go about the completing the square business, right? So we look at b. b is 2. Half of 2 is 1. 1 squared is 1. So I'm adding 1 on the left, but what am I really adding? 25. Very good. I'm really adding 25. So that's what I have to do on the right. Okay, so half of 20 is 10. 10 squared is 100. So I'm adding 100 on the left, but in reality, I'm really adding 16 times 100, right? Which would be 1,600. Okay, so now let's clean it up and get it factored. So I've got 25 times x plus 1 squared plus 16 times y minus 10 squared is, I add all those numbers up and I get 400. Now, the 25 and the 16 are different numbers, okay? This is not a circle, this is an ellipse. So I need that back number to be a 1. So I'm going to have to divide each of these by 400. I have to divide everything by 400. Okay? All right, so 25 over 400 reduces to 1/16. So I've got x plus 1 squared over 16 plus 16 over 400 actually reduces to 1 over 25. So I have y minus 10 squared over 25 is 1. Okay, how are we doing? Okay. So our center is actually going to be negative 110. Okay. So I want to talk about the graph. Now you've got a couple of options. the graph isn't big enough. There's only 1, 2, 3, 4, 5, 6, 7. There's only 8 spaces each way, and that's 10. So here's your two choices. You could go use ones and go over 1 and up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could do that and graph it off of the grid. And that is perfectly fine with me. Not a problem. Okay, you can totally graph it off the grid. It's okay. Now, the other choice would be to take the grid and make it a different scale, and I'm going to work on that with you today. That's what we're going to do today. I'm actually going to say that this scale is by 2s. If you change the scale on your work, you just need to write me a note. What is your scale? This scale is by 2s. So when I go to graph -1, 10, the -1 would actually be like right here, right? Let me make this a little bigger. So we're graphing -1, 10. So -1, since this I'm by 2s, -1 would be here and 10 would be 2, 4, 6, 8, 10. It's actually going to be right here. Now, if that really troubles you and you don't really like graphing like that, don't worry about it. Just graph off of the grid. It's okay. So the number under the X is a 16, which means that the square root of 16 is 4, which means that I go 4 spaces to the right and 4 spaces to the left of my center. So, and our scale is by 2s, right? So I'm going to go 2, 4, and 2, 4. There's the edges of my ellipse. Okay? Now, the number under the Y is 25, so the square root of 25 is 5. So that means I'm going to go up 5 and down 5 from my center. So up 2, 4, 5, and down 2, 4, 5. And now those are the boundaries of the vertices and co-vertices of my ellipse. And so I'm just going to connect them. Now, of course, if you were graphing with 1s, with a scale of 1 instead of a scale of 2, your graph would be, bigger, much bigger than mine, right? It would be twice as wide and twice as high. So it's totally your choice whether you decide to change the scale of your graph, or just graph off of the graph. Perfectly fine either way. Okay, how are we doing? Now for the ellipse, we really just want the center and all the edges. You don't have to graph the focus if they don't ask you to. And they're not asking, they're just saying to graph it, so we're good to go. Okay? All right, last one. Bless you. All right, so let's take a look at it in general form, try to figure out what we're dealing with. So I've got an x squared and a y squared, and I have a subtraction. Okay, if either of those terms is negative, the 25 or the 1, whichever, this is a hyperbola. This is a hyperbola. And with hyperbolas, it's the second fraction that's negative, right? Not the first one. So when I rearrange these variables, I need to be sure that I'm putting the x one second, because that's the subtracted one, right? That's a minus 25. So let's kind of think through this process. So because the y is the positive one, it's going to come first. So I've got y squared plus 20y. Let's make some room. My x squared is negative, so it's going to come second. Minus 25x squared plus 50x. Give some room. and move the 50 over. Okay, so I did that intentionally. We have to be sure that the negative fraction is second, not first, with a hyperbola. And the hyperbola is the only one that should have a negative fraction. All right, so let's work on completing the square. So there's nothing to factor out from the y's. That's a nice little treat. Y squared plus 20y. I do have to factor out a negative 25 from the x's. Okay. Now, here's where I see the most mistakes. When I'm factoring out a negative 25, a negative number from two numbers, what is going to happen to this sign right there? What is going to happen to it? Is it going to stay positive when I factor out a negative number? No, it's going to change. Whatever it is, it's going to be opposite of what it is now. All right, so since that was positive, that means that this sign now is going to be negative. And I'm really kind of exaggerating talking about it because that is, I promise you, is like one of the most common mistakes that I see, is that that sign is usually not adjusted as it should be. Okay, so let's do our completing the square business. So start with the y's. Half of 20 is 10. 10 squared is 100. 10 plus, so plus 100 plus 100. Okay, that's kind of nice. Okay, half of 2 is 1. 1 squared is 1 plus 1. But I'm really not just adding 1, am I? I'm actually subtracting 25 is what I'm really doing right here. So I'm going to subtract 25. Okay. All right, so let's clean this up. So I've got y plus 10 squared minus 25 times x minus 1 squared equals, I add all those numbers up and I get a 25. Now this is a hyperbola, so it's supposed to equal 1. So I'm going to have to divide everything by 25. So we've got y plus 10 squared over 25 minus x minus 1 squared is 1. And you can put this over 1 if you want to, or just leave it as x minus 1 squared. Okay, let me pause there for a moment, see if we're all okay. Okay, is everybody okay? Okay. So when graphing a hyperbola, we need the center. So let's just write the center down. The center is 1, negative 10. So we're going to have the same issue. 1, negative 10. It's going to go off of the graph, or I'm going to have to scale it. I'm going to go ahead and scale it just so we get more practice with scaling. Again, you don't have to. You can just graph it off of the grid. It's really whatever you want to do. So we're going to do the scale by 2's again. Okay. So I've got 1, negative 10. Let me just make this a bit bigger. 1, negative 10, 2, 4, 6, 8, 10. Okay, so that's where my center should be. So the number under the y is 25. That means the square root of 25 is 5. So y is vertical up and down. And this is the first fraction, the y one. So this is going to be a vertical hyperbola. Right, this is a vertical hyperbola because the little pieces are going to be facing up and down because y is first. So I'm going to go up 5, which would be 2, 4, 5, and down 5, which would be 2, 4, 5, to put those are my vertexes. Both of those are vertexes. Now, do we remember, without me moving it, what number was under the x's?
1.
Was a 1. Was a 1. And so the square root of 1 is 1. So I'm going to go 1 to the right and 1 to the left of my center. Now, if you recall, when we're graphing hyperbolas, the easiest way to do it is to graph that little dotted line box that connects the, I'm going to call them vertices and co-vertices. They're not really co-vertices, but that's okay. Okay? And then remember, and I don't trust myself without a ruler today, so remember, we've got to draw the little asymptotes that go from corner to corner, which helps us graph the hyperbola more accurately. Okay, so we're just going to go from corner to corner so that the shape of the hyperbola will be more accurate. Okay, so recall this is a vertical one. That means that the hyperbola pieces are coming out the top and the bottom. So they would come out here going this way and this way. And then out of the bottom would go like this and like this. Now, if the X one had been first, then they would have come out the sides, right? We talked about that last time. All right.